specific design, we can use additive manufacturing. Now, so I will just try by all means to summarize. So the aim of this study is to apply additive manufacturing as an enabler for local component manufacturing. And there is need for us to come up with tools that can guide industries on how best to identify suitable application of additive manufacturing, and also to identify potential parts that we can actually investigate on. And obviously we need to look at different materials. So as part of this study, the first point of call was to sort of develop a selection matrix that can actually be used to identify components that can be suitable for additive manufacturing, looking on the technical side and also on the economic side. So this actually involved looking at the part, the complexity of the geometry, the production volume, how critical the part is, and what are the opportunities for design improvement, because we can actually improve the design. We can ensure that the design is more function-oriented. There is less wastage of resources. So that was the first part of the study, and this particular matrix was evaluated using case study components that were already in existence, just to verify that this matrix can actually work. And then the next stage was just to come up with an implementation plan that can actually be used when you want to implement additive manufacturing in your operation. Obviously, you need to identify mainly the problem components, the problem parts, see what kind of technologies, what AM technologies that can be applied, compare these particular technologies, looking on the cost side, evaluating the application, and then obviously you need to do some simulation to see how the part can perform under the different conditions. So that was the next thing. And then we also looked into different parts, and then we look at what kind of materials can we use, what are the alternative additive manufacturing process. So this is a spare part. We looked at 3 materials and how they could perform when they are subjected to the operating conditions. We did some simulation to see how the parts can perform, and we could actually recommend a material. And we also looked at the cost. In this particular case, we recommended the wire-based additive manufacturing process. And then we looked at another component. We also evaluated like it's tough PLA material, how best it can perform to withstand the operating conditions. And then we also have another project which is going on. This is a brake caliper component. This project, I am doing it with a student who actually had to first come up with a simulation model of the parameters that would work best in order to ensure that the quality of the part is in line with the required operating conditions. So it is still under testing. Then another concept that we are looking at is on how best maybe we can develop a mobile smart factory which in which the part is produced on site, on demand. But then the main challenge was if we were to use this for a metal-based process, like the powder-based process, it would be a problem because the powder itself can be a hazard. in terms of movement, some of the powder materials. So we propose that maybe to have such a system, we need a wire-based system and also a polymer-based system. So I'm just going to rush down to conclude that there is still some work which is ongoing, where we are looking at different materials. We are looking at the aluminum silicon ion, alloy, and then polymer parts as well, and see how they can perform best. We do have another project going on for other aluminum-based alloys. So I can say in conclusion that additive manufacturing is an enabling technology for increasing local production of parts, as long as we are able to identify the right application for the technology. In other cases, it might not be economical to fully utilize additive manufacturing, but we can have a hybrid type of situation where we do have a combination of additive manufacturing and a conventional process. But we still need to do further research because this is like an emerging technology that we want to use, especially on the area of spare parts. And obviously, we need to keep on doing further research on the quality of parts. So I want to take this opportunity to thank you all for your attention. Thank you very much.
Thank you very much, Dr. Muvunzi. I would like Dr. Muvunzi to sit down. Is that okay? Yes. Are you comfortable?
Yes. Thank you.
How are these chairs?
I feel like a chief.
Okay, super. So what we're going to do now is we're going to have another panel. You know, I think it's going to be more efficient for what we need to do, rather than the format that we have been presenting in. So I'm going to call to the front Trevor to join the panel and be a chief also. Bring along your laptop so that you can speak to the questions that I'm going to ask you. So I'll ask each of you questions that are related to the work that you're going to present, and then we can, I guess, sum up more promptly, because there's still quite a long evening before us. So if we do not increase the efficiency, we are not practicing what we teach as industrial engineers. Is that correct, Charles? And then there's Alliance. Please come along with your device as well, and make sure that your device is open, because when the questions start coming, you're going to be given 1 minute to answer. So as Alliance is coming, Nogulung, where are you? Are you here? Are you coming? And then there's, so these are the people who are here. Is there somebody that we have missed, who the computer has skipped? Online, are there people online? The members who are online. Yonga, are you there? Yonga is no longer there. Okay. Dr. Ogbodo, are you there? Is Dr. Ogbodo there? It looks like we've lost Dr. Ogbodo. Dr. Aderoba? Is there somebody who's looking at the screen there at the back? Can you confirm if the members are there? But he's not responding. If he is not responding, then he's not there, Musa. Yonga is online, but he must respond for himself. No one can respond from another country and say Yonga is online. He must respond. Are we together there, Yonga? Are you there? Yonga is not there. If he's there, he would have responded, isn't it? So it's okay. But I'm aware that there's... Neo, are you there? Neo, are you there?
Neo, are you there? Are you there?
I see she's unmuted, but we can't hear her. Is it us here, who, and the technicalities, colleagues, if you can please assist? Maybe you can put on your video now so that we can see that you are alive. I hear there's load shedding in Pretoria.
I hear there's load shedding in Pretoria. I hear there's load shedding in Pretoria.
Okay. So while the online guys are being sorted, we'll start off with the guys that are here. So what we are going to do for this panel, we'll ask them specific questions. So I think I must emphasize that our judges need to be really fast awake. So we'll ask them a question. Judges, you need to be very attentive. Listen to their graphic description of the response, and then you can make a decision based on that. Is that okay, judges? Any clarity required? So the judges are up to speed. So I'm going to start off with Nogulunga. You got Nogulunga? You got Nogulunga? Fantastic. So, Nogulunga.
Fantastic.
Can you please introduce your work and the title and why it is important for Gibela or the transport manufacturing sector in general? The battery is flat.
Good afternoon, ladies and gentlemen. I'm Nogulunga Dlamini, and I'm currently focusing on immersive virtual work integrated learning. The setting that we're at now, where we have our grade minds, our undergraduate students who have just, presented their posters, our grade leaders from industry, and also our executives like Prof. Munda and Prof. Mbofu. That's the setting. That's what we need to have this immersive virtual work integrated learning. That's what the topic I have, immersive virtual work integrated learning, as a scoping review. Thank you.
Thank you very much. Bibili, your topic and the introduction around your topic.
Okay, I hope you can hear me. My name is Alliance Bibili. My topic is actually qualification model for additive manufacturing application in the rail industry. The fact that we've discussed a lot about greenhouse and climate change issues are the main drivers of using lightweight material in the transportation industry, because 27% of the greenhouse emissions are from transportation. So the use of aluminum for trains, for high speed, for also resistance, and also reducing the fuel consumption. Because remember as well, there is for every 100 kilogram of weight reduction in an automobile, a fuel savings of 0.3 to 0.5 liter per 100 kilometers is possible. So that's what I can say for the use of lightweight material in transportation.
So it means that the Gibela trains will use less ESCOM.
Yes, because even
that will help ESCOM a lot, actually.
Yes, for the train as well, you save energy. For the braking, for the stopping, you still need to use more energy when you are braking and when you are stopping. So those elements also take into consideration the lightweight use of material, the use of lightweight material in the rail industry.
Thank you, Alliance. I think those are global problems. With the climate change, I think that also in a way contributes to climate reduction of the climate impact of our transport activities. Mr. Chiwundla, I hear that you are doing doctorate now. your topic and its importance and an introduction to your topic before we go to the next aspect.
Thank you very much, Prof. My topic is around product service systems. The title of my PhD proposal is the application of IoT in product and service development. Previously, the application was around the brakes of the train, where we looked at how we can use sensors to remote monitor the brakes and improve safety and maintenance of the train. But going forward, we'll look at other components of the train, where we're looking at real-time monitoring using those sensors, but also with a business case of saying what other components can we sort of make smarter, because product service systems is actually about making the product smarter and actually adding the service element part of the product, which is what our country needs right now. I think the manufacturing industry has lost a lot of jobs in the past few years, so we need to look at how we can incorporate service using technology to make our country look better, but also the rail sector. Thank you.
Thank you very much, Chowundla. Just to check the colleagues online, I saw that there's load shedding all over Pretoria. Next time, I think it's a noble thing to be here. You know, where we are, there's normally no load shedding. So, Thierry, are you able to speak? Though there's load shedding? Though there's load shedding?
No problem, can you hear me?
Yeah, we hear you, but you sound like you are far away. Yeah, we hear you, but you sound like you are far away. We hear you far away. Far away. Far away.
Okay. I can also get the echo then. The echo may be
We
some
check
here
outside.
there.
There could be somebody who's outside who's logged in. Thank you very much for that assistance. So.
I am actually very close to the computer. Can you hear me?
You were saying, Doc? You were saying, Doc? You were saying, Doc? You were saying, Doc?
Yes. I asked Younger to move closer to his mic. Younger, you have mic.
I'm actually very close to the computer, but I can get the noise, the echo effect on this side.
Okay, wait for the echo to die down. Wait, I think for the echo to die down. Wait, I think for the echo to die down. Wait, I think for the echo to die down. Wait, I think for the echo to die down. Wait, I think for the echo to die down.
In the interest of progress, I would suggest that we just unmute the colleagues online. And then at the end, when we are done with the colleagues here, because I think it was flowing nicely, we can then come back to them. If ESCOM is failing us, I think we can just label there next to their presentation, HCOM. And then they will have to do that when we go back to campus. Or another alternative is that they can send through their PowerPoints to Humuto, and then, or is there, I think some of them have got posters, they can send those through, and then the judges can have a look in the interest of fairness. So coming back to you, Noglunga, you've introduced your topic, and I would like you to speak to the literature around this immersive technology. I think it was a burning issue when Skosana was here up in the front. Maybe you can corroborate the issues from a different angle. And as you speak about the literature, maybe proceed to the methodology that you utilize, so that we deal with both aspects of the literature and be clear that this is about the literature, and then proceed to the methodology. Thank you.
This research, we need to cooperate, to integrate the undergraduate students, the industry, and also the academia, so that we solve the scarcity of the problem-based work integrated learning. So there's findings and studies that have proved that using virtual reality and work integrated learning can solve the scarcity and the scarcity of placement-based work integrated learning and the negative effects that COVID-19 has done. So that's what's the aim of this research. The research is there's previous studies that have adopted this concept, and they are providing the benefits of it, and also the methodologies. Since it's work integrated learning. There've been a methodology that is learner-centered, focusing based on the learner. There's also methodologies that have been focusing on problem solving in creating those virtual reality aspects and work integrated learning activities. And also there's been the human-centered, so there's different methodologies that one can look for in solving this, because we are using students here, which we can focus on learning theories, maybe the learning outcomes, also the human-centered, like the economics, looking the whole holistic human-centered, and also the problem-based objects of how are we integrating these activities so that students are able to learn and grow in their field of work and also in the professional community that they are. Thank you.
Thank you very much. So in your methodology, you're working with students to immerse them in this virtual environment and then declare that they've experienced work integrated learning. Am I understanding you correctly?
Yes, and also focusing on the problem-based activities. Just like we said, we need to integrate each other. We need the industries to give us problems that we can have, focusing on them being problem-based and experimental based on this program. How are the students bringing what they've learned in class? Like what have they learned in class? How can they bring this knowledge, these theories, to solve problem-based or also human-centered or learner-centered? You can integrate also those methodologies because it's a holistic thing. It can be problem-based, focusing on the problem that the industry is having, and also learner-centered, the learning theories that they've learned in the lecture halls and everything. Yes, thank you.
Thank you very much. Moving right along. Bibili, literature and methodology from your end.
Thank you very much. So for the literature, we selected our keywords to start going into database, TUT database, science, direct. So the first keywords that we looked at was the word aluminium. We also look at the qualification parameter for additive manufacturing, and we also look at the different additive manufacturing technology for metal components. So the first question that we ask to ourselves is, why should aluminum be adopted for trains? Because we found out that the rail industry is overwhelmed with steel materials. But we found out that aluminum material is 3 times lighter than steel, and also is characterized by high corrosion resistance, high strength. It yields better physical and mechanical property, which also secure lower energy consumptions. So with my co-supervisor who is working at the CSIR, we also found that in the literature, the aluminum silicon 12 is not well discussed about, is not well reported. So we found that a gap in that sense, that it's a material that yields better characteristic, but it's not well used in the rail industry. However, in the aerospace industry, it's definitely used because in the aerospace industry, the lightweight material is overwhelming, and also the use of additive manufacturing. So for the methodology, we use design of experiments to ascertain the quality and also the mechanical and physical properties of the material that we want to use. So far, the work is in progress, so that's what I can report for now.
Thank you very much. Bibili, I'm actually seeing that maybe there's an opportunity there by virtue of the expensiveness of these additive manufacturing machines to take a virtual reality approach, you know? Maybe at the beginning, before you get to the real material, so that you're able to train students virtually. And, you know, I'm just putting that there on the floor, but maybe you want to comment back, it's okay, given that we are in this format.
Yes, that is a possibility that we can consider. However, for now, we've started printing the first samples. So we got results because we were varying the laser speed and also the laser power. So we are actually looking at optimizing the parameter that can yield the optimum characteristic of the material. So we can benefit of that material.
Thank you very much. obviously not for your study, maybe somebody else's study, but there could be that opportunity to do that. Trevor?
It's, I think there's been a discussion about revitalization of the rail sector, and part of it is making sure that the trains are safe if we're going to make trains the main mode of transport. So part of monitoring and maintenance of those trains is an integral part to ensuring that those journeys that those people take every single day is important. I mean, is covered in that instance. So we need to look at how available data in those trains can be used in an integrated manner, and we can look at how permanent line failures can be solved in that, and also train congestion. Sometimes the trains are full and other maintenance issues. So the method that I've used in this aspect is looking at what are the knowledge areas, first of all. Like if we're talking about PSS, we're talking about 4 knowledge areas, and one of those is the Internet of Things. And within the Internet of Things, there's gaps and problems that you can find within there that apply to rail. Now, in my work, I've developed a framework where I'm looking at what we call service model canvas. It's actually an extension of the business model canvas, but now it's looking at how can we take that data that is available and use it to get that data and then solve these problems that we are having. And maybe have some sort of a dashboard where we are able to monitor some of those components in the train, but we can also extend this to any product, because at the end of the day, we want to look at how do we make products to be smarter, and how can we develop those business models that at the end of the day, we've been talking about commercialization. How do we commercialize our research at the end of the day? Also developed a simulation around that, which looks at, as I've said, I've looked at the brakes. I've developed a simulation that will look at the bogie and what's happening actually in the bogie, each component around the braking system.
So that the printout of this object is already in a state where it can be, utilized in the appropriate context. So that, I mean, now that you're sitting as a panel, people are picking editing, people are picking visualization. How do we not look at these technologies as silos, but find a way of integrating these approaches and, getting to the goal that we want to get to in terms of the 4th Industrial Revolution. Obviously, I'm going to give the audience an opportunity to reflect on that and express what they think, because I think sometimes we talk about these things. I mean, when it's presented as a PowerPoint, you always see it individually. It's this thing and that thing. But when they are presented together like this, you begin to see things from a different perspective and begin to ask other questions you wouldn't have asked, whether it's from a commercialization perspective, from Dr. Martin, or from the approach in terms of doing the R&D. Hi, Neo, are you there?
Yes, Prof, I'm here.
Yes. You look bright and early. Late this afternoon. Okay, please. Proceed. I think you are showing your face. Some of these matters are touching you, and you want to deal with all of them at once. So you can proceed. Tell us your title, your introduction, your literature and ideology, and then you disappear. The door, and then you disappear. Hi, we are back. Hi,
Go ahead.
Okay, I'll just keep on talking, but then I can hear there's echo. I think one of you should switch off the mic. One of the mics there.
So you can keep speaking, Kenna.
Okay.
So,
Okay. Thank you, Doctor. Okay. The topic for my work is development of a processing map for high performance aluminum based parts for the automobile industry using selective laser melting. Seeing it is that the failure of rocker arm is a major concern as it is one of the important components of the pusher rock internal combustion engine. The reason for the rocker arm optimization with the durability, the toughness, the high dimensional stability, the wear resistance, the strength, and the material cost, as well as the economic factors. So the current materials in the market, such as the steel and the aluminum that is currently used, the current materials in the market, such as the rocker arm fatigue, the bending load, where the carbon builds at the end of the valve, and the friction, which makes it crucial for the new alloy design and property optimizations. So recently, it has been a point of major research to focus on improving materials properties. So several materials have been investigated by the material scientists, but one of those materials is aluminum alloy. It has received more preference in the transport industry. So the aluminum alloy have a lot of potential automotive in the aerospace industry due to their lightweight and high strength to weight ratio. So on the literature, and the aluminum silicon 12 alloy. So basically, they looked at materials property findings were exciting, yet there's a room for improvement since the parts produced still show some failures. So from the literature, I learned that authors study the same alloy but varying the parameters. So if I can optimize the parameters and I add the additives to this alloy, the aluminum silicon 12, definitely I can improve its wear, the compressive, the fatigue, and the fatigue of the pad. By the MN, I mean the additives, I mean the manganese. When manganese is added up to 1.5%, it strengthens and hardens the alloy, and it improves the cycle fatigue resistance. And when copper is added up to 6.5%, it increases the tensile strength, the fatigue strength, and it hardens also the alloy. So that the literature and all the information, it led to the design of experiments by the Takuchi approach. So for the optimal selective different levels. So for the base alloy, which is the aluminum silicon, which is the base, and adding a copper to it, then it will give us a binary alloy. And then thirdly, we have a quaternary alloy, which is the base, the copper, and the manganese.
Yes, thank you very much. Judges, if you can show by thumbs up if there was an element of clarity in terms of the aluminium that the candidate is talking about and what they want to do with aluminium with using the additive manufacturing process. Super. It's better than... So well done, Neo. I think the judges are happy there. So coming back to the colleagues who are here, I think they may necessitate you guys to just send through your PowerPoints to Humutso, because it's an issue of checking reference. Guess those references, you can't read them out one by one. So it's a matter of those PowerPoints going to Humutso, then Humutso can share it with the judges so that they can just, you know, go to that slide of the references and then they deal with that matter appropriately. So at this juncture, I want to open up to the room for 1, 2, 3, 4 questions. Each, actually 4, because it also includes Dr. Muvunzi, right? She didn't get an opportunity to be asked questions. You have 1 minute to ask your question. You can't ask a question that is long. 1 minute to ask your question. You direct your question to a specific member of the team. That member also answers in 1 minute. It's 1 minute ask, 1 minute answer type of questions, isn't it? And then when that, each of us, the 4 people from this side, they are asking separate individuals here, not, you can't ask the same person. If somebody is asked Nogulunga, you can't ask Nogulunga again, you must ask somebody else with respect to the work they are doing. And just to jog your memories again, I'm just going to remind you, Nogulunga is looking at immersive VR technology learning. Bibili is looking at additive manufacturing, utilizing aluminum silicon 12 for the rail industry. And then Trevor is looking at the application of IoT devices and development of related services. And then Dr. Muvunzi is looking at enablers for local component manufacturing in the transport sector, and specifically she focused on additive manufacturing. So I see their hands. Dr. Dan, is that 2 hands? No hands now. Okay. I saw there was that a hand, Busiso?
Yes,
okay,
Professor.
just hold on. I just want all the hands, because I'm going to have one. You can't ask a question and like the other question that was asked made me ask this question. If you've got a question, you've got a question. If you don't have a question, you don't have a question. Are we together there, Maringa? You don't have a question? Okay. So Siso, Luvuyo number 2, and yeah, but then these guys are also then welcome if they've got two questions each. So the floor is yours, Busiso, for your questions.
Thank you, Professor. More related to Nogubonga. I had the concept on you and incorporating undergraduates, postgraduates, and also everybody at large. So I didn't get how you go about implementing that. I don't know. Please just give brief on that. Thank you.
Let's get all the questions on board, then we know that we are getting answers. Thank you for being efficient with the 1 minute.
Yeah, Prof.
Hello. Okay, my question is actually to the 2 ladies that are doing additive manufacturing. So I guess, Prof, I get 2 minutes because I'm going to ask 2 questions. So the 2 ladies that are doing research on additive manufacturing. So because, you know, even last year there were a lot of presentations that were regards to additive manufacturing and the benefits of the manufacturing process. So according to you, is there debate to be had in terms of why is it not taking off? Because I remember in my previous life when I used to be an engineer, we were also researching additive manufacturing. In this job, I've researched. And then Ms. Bibili, my second question is to you with regards to the use of aluminium, specifically in the rail industry. Because scientifically speaking, rail uses the least amount of energy to operate. It's been proven. And then in aerospace, they actually use aluminium because they use fuel. So the use of lighter materials is beneficial because it's offset by the cost of the fuel that they save. So in rail, seeing that the cost of aluminium is very high compared to stainless steel. So what would get if I use